Hello chaps, so this is going to be a long technical discussion video to discuss some of the work that was done recently. Probably noticed the RC creations, playing with RC molars and the derivative vehicles and so forth. So first let's backtrack to a long time ago to the Mobat and what was before the Mobat, which was the Tamiya 125th scale motorized tanks, which I felt were the essence of the ideal size motorized vehicle for a 3" and 3/4 figure, like a Joe figure. So this is what they've done. You know, they didn't take a 1/18th scale, they didn't take a 1/16th scale, they took those 1/24th and 1/25th scale motorized tank, which they eventually stretched for the Mobat and for the Molar. On some of my older videos, you might have noticed when I took the vintage Bandai M60 motorized tank, and although it's all made of plastic, it's an obscure ancient tank, not as refined as the Tamiya. Its prowess on terrain, scale-wise, was way more satisfactory than the Mobat and the Molar. The Molar used extensive modifications and still had shortcomings of the proportions, the weight, and a bunch of things. So it shows you that reality that, you know, fantasy is fun, but the proportions of a tank, like the angles of attack and whatnot, they do matter. You know, the biggest flaw in the Molar is those rigid mud guards in the front and get stuck on things. I don't want to criticize the Mobat as a toy, because as a toy the Mobat is fantastic. It's simplistic, it's great. Now when we move on the Molar, we start to enter tank realism and it becomes fun. So I feel that as far as Molar is concerned, we added the suspension, it got fun, and then I moved on with, you probably have seen this, which was the Cobra Swimming Tank. And now it's time to discuss the findings. Is that this swimming tank, or this new platform, I don't know what it's called. So it started with a prototype, what was it, the hull number 7 was it? And essentially, it was aiming for the Wolverine size. 5 road wheels, narrow track, much more compact. It was really based off the Wolverine. And then the Cobra Swimming Tank came out of it. So it was very, very striving to be the essence of the tank, which was leaning toward the T-54. So for those who don't know, it's the ancestor of the T-55. So we're talking about round cast turret. We're talking about, hold on, wrong file here. Let's hide the Molar decoy. We're talking about a cast turret. We're talking about the essence of what the tank is. A minimalistic, what do you call it? Hull, and a very efficient drive system. And this was kind of a shot in the dark. I was here on the computer, since I was limited by not being able to print the hull in one piece. I was tired of hacking, using glues, and trying to use existing Joe vehicles for the purpose, because they have so many flaws as far as to, you know, bring them to a realistic RC vehicle. The Molar being the least of them, but the Molar issue when I was playing in the snow was the ground clearance. It doesn't matter, it was too much of a belly. If the figures were smaller, it would work if you could raise the belly plate. I didn't want to do any surgery, and, you know, the Molar is a great toy, let's leave it as. Now you might say, why don't you just drop the, you know, increase the suspension travel? Well, what happens is the geometry is like, if we drop the wheels too far down, we start to a very abrupt angle, or it gets weird. I know on some tanks they do that, but it has issues. Believe me, it has issues in geometry. The one thing I did on the Mauler, some of you might have noticed, is I dropped the front idler. The toy, the way they did it on the G.I. Joe Mauler is they have those bumps on the hull front, and they're kind of concentric with the front idlers. And that's a toy safety sturdiness solution kind of thing, so that if the tank hits things and the child puts all his weight, not only there's a strong metal shaft, but the hull is going to bottom out, so it's not going to flex the shaft and the wheels too much. But it hindered the performance. So on the Mauler, what I did is I actually dropped the pivot of the front idler to increase the clearance and also bring the idler more forward. So this is the first thing I'm going to bring in this discussion here is, let's talk about the geometry of the front idler. On the Warthog, I did the same thing, which is when there's terrain, typically the tank is going to sink, the suspension is going to collapse, and the idler with the track, it is going to collapse and it's going to sink in the ground. And then if you have a traditional hull, which typically would be around here, the Mobat, you know, or the Mauler, then you start to, I don't know what the technical term is, you beach it, you belly it. So basically your belly and your front nose is touching the ground. When the belly or the nose is touching the ground, you lose grip. And I used to hate when you look at the T-72 tank and a bunch of other tanks, even on the Abrams, I don't like how the clean hull is broken by the tracks protruding forward and then the nasty little mud guards. Well, there's a purpose behind that, and the purpose is that we need to have the track further down and forward from the belly and from the hull, so that when the vehicle sinks, here, if I'm going to do this here, when it's going on terrain, we want to minimize the amount of contact of the hull and the nose so that the tracks can bite and provide grip and move forward. So in this vehicle here, that swimming tank, I don't know what you call it, what I've done here is I started with a T-54. It didn't feel Cobra enough, so I went with this aquatic shape, meaning, yeah, let's make it amphibious submersible. So go futuristic, inspired by the Hammerhead. It went into this little sleeker shape. And then the reality is, in tank design, they would have plates. So in World War II, you would have one plate here, then welded there. So I always felt that there was a hard edge at the nose of a tank. And if you notice on most RC vehicles, you will see that the hard edge is scratched up. If you play a lot with an RC Mauler, no matter how good it's tuned up, that front hard edge is scratched and scratched because it's a hard edge eating all the rocks, all the obstacles. It's really dragging. It's almost like a bumper. And on some tanks, if we look at the Leopard 2 or Leopard 1, they didn't do two pieces. They have an intermediary piece. But you think in times of manufacture is that we have one plate and then we have another one, we weld it, done. Now, when you have a third plate, it's additional work. Well, here, since I'm 3D printing it, and since it's Cobra and fantasy and aquatic, I said, well, it's the future. Cobra is 3D printing it, making it out of polymer or plastic, you know, it's disposable, it's Cobra. I went organic, so there's a smooth shape. So it's more like a boat. I was not hindered and limited by the factors of the real life, which would be, oh, we have to manufacture this tank and it has to be made in a normal way. The exception, of course, here, some tanks, Americans, Russians, were cast, so they could have some angles or some curvature. But I've noticed that it's typically, if there's a very organic curvature, it is thin armor. And typically when it's thick, you know, projectile-resistant armor, they tend to simplify the shapes. So here we have this liberty that we have this boat-like shape. It's a curve. And the purpose here, you can see there's a remnants of a former design station here, is that implied that this pivot or this knuckle holding the front swing is really protruding like crazy. But it's really a boat. And why did I do this? Initially, it was much higher. And then I was really thinking in terms of being a watercraft. since it was going to swim before it was submersible, thinking like a boat hull, it's like, okay, this was the line that felt to me more natural for being amphibious. So this was chosen. And then to accommodate the suspension, this part here I'm gonna grab this guy so you can see. Let's give this green part here, was changed and refined several times to adapt in the staggering, the spacing of the units, but also in positioning and the mounting, obviously for strength. So initially, each station was independent, and you would screw it like I've done on the Warthog or the Mauler. Then I got tired because when you print a lot of parts and you butt them together, there's some discrepancies. So I came with the idea of, you know, let's have a runner, and I can cut it later, but let's have a runner so you have the proper spacing. So this was a solution that simplified a lot because it's a pain in the butt. And what I found out when I made the stations individual, is that the swing arms were not in line. Some were bowing out or in, depending on the assembly, and it became a nightmare. And I've had the same issue on 1/35 scale miniature RC tanks. And it's like, okay, the solution I found on smaller tanks was to print the hull one piece with all the mounting holes already in the hull. Then the individual stations can be bolted, and if it's printed one piece, the entire hull would have the same alignment, the same plane. So there wouldn't be any discrepancies in alignment along that. So that was solved on smaller tank. On this one, however, the hull was made of 4 different pieces. Let's see if I can show you here. And this is funny because it reminds me of how the Germans were making submarines in World War II, is that they made them in sections and they would assemble it elsewhere. And there are a couple of reasons for this: logistics, but also, you know, if one section's built somewhere is destroyed, you know. So here for Cobra, I was kind of fulfilling and following this kind of thing that Cobra maybe is building those things clandestinely and you build it in sections. For me, it was being practical, is to be able to print those things. Here I have them. And because large prints failed, I use ABS and there's lots of warpage. It's like, well, I did a test. Too big would fail. I tried to make in 2 pieces, and I ended up being successful in making the entire hull in 4 sections. And then I would send them, and I would orient to print the rings up. So I would print this one this way, print this one this way, so that the curvature was as accurate as possible. The base would warp, and I would send that. And then later on, I use inserts to guide, to butt join those things, and use glue. I was able successfully on the first gray tank, the first one you saw, the reveal, the gray one. That one was able to join all these sections with very little mismatch and a lot of sanding. That's the thing which is similar to military manufacture, is how to make it easier. See, I'm a one person, so whenever I have to build those things and I have to send it, if I spend more than an hour sending things and I have to do for each one of them, it becomes long in the tooth. And I'm striving for a way that enables me to replicate, duplicate, print or make the same thing over and over again with the least amount of effort, and try to not make it a chore. And in the real world is how they try to simplify the manufacture of the weapons so they can make more to crank them out. So that's a similarity that's kind of challenging and it's kind of interesting. So I was able to make the first hull, and it was a shot in the dark. I discovered with my water test you've seen in the video, when I put it in the water, not only I could make this float, I could also make it sink by playing with some foam pieces, trapping air. Let's see if I can show you here. There's air trapped in this thing. So this was designed from the get-go to trap the spoonsoon. There's air trapped in the front, air trapped in the back. So there's chambers. And then I was able, by playing in water, so yes, I could have done this with analytics in the computer, but I kind of like old school as a kid, to just do something by gut feel, play around with it, and then see what happens. But I was able, by placing some small foam blocks and different weights, I quickly achieved neutral buoyancy, and then I was able to make it sink and make it float. And there came the idea of this tank is not a swimming tank only, it's a submersible. So it can hide at the bottom of the lake, of the pond, it can float, it can surface. It's very exciting. It's, oh, this is kind of new, it's Cobra. I mean, if the G.I. Joe shark can fly, I mean, it's not that unrealistic for a tank to be submersible. In real life, it's a nightmare when tanks go through water. The crews hate it. But here, it's like it's Cobra, and when they do it, they don't close the hatch. The tank is not kept dry when they dive. They flood the compartment. So that's why you have eagles and divers on it. The tank has water everywhere except in the key areas, which is flotation and the power units. But the tank can sink as a submersible. And then if something happens, that's why if you notice, the tanks never had hatches. Well, because it's like those midget submarines that was used for sabotage. Is basically you have divers riding a weapon, and if something happens, they just ditch it. And that was the essence of the tank. That's why there's no hatches. The guys are just riding it, and if there's slightest problem, just abandon it, and that's why. So going back on the foundings here, let's see you the different sprockets there is. So there was the wide track for the Panther that was used, and there was the narrow track from the Panzer III, all in 1/16 scale. So I'm going to hide it. So I spent a little extra work on this to accommodate both. The Panzer III or Panzer IV track has a single horn, and I was able to accommodate both type of tracks. So on the Panther, there's dual horns, and I'm only riding on half the track, and it works fine. From experience, it didn't throw a track, it worked pretty well, and the tank is light enough to not bend or do weird things. So here's the Panther drive sprocket. In comparison, you can see here the horns from the Panther track. So I spent extra time to design the hull to accommodate both tracks, because if I only used the Panzer III track, I could have made it actually closer. And I had to think of the suspension arms. So the suspension arms, actually, there's a thicker spacing here. Let's see if I can, let's go on the front here. Let's go here and go here. There you go. There we go. So I could have sped up the design of it, but I spent extra time, and you see the amount of thickness of material here, is if I only used the narrow track, it could have been closer to the body, the suspension, the track, everything could have been closer. One of the main goals from the get-go of this design was to make it same width as the Wolverine, if not narrower, in order to fit the cargo plane that our friend Action Robot Punch is making. Since he's able to fit the Wolverine in, I said this would be that would be really awesome if our tank could fit in a plane for transport, because neither the Mobat can, neither the Mauler can, and in real life, the real life Mauler, the RD, I forgot the name, high survivability test vehicle tank, whatever. The real life Mauler tank was actually the size of a Sheridan. It was much smaller. It would be closer to the size of the Wolverine, and it was meant to be air transportable. So that's another thing I was trying here. So I was playing around with the width of the gearboxes here, limitation being the shafts, because this is a gearbox with dual ends. Some don't have it, but I consider that. So the closest I could is to get this even closer like this, and they would touch. The other factor was the crew. Is I put two figures here. Let's see if I can find them. Let's see if I can find them. Okay, no, they're not. I moved them. But I took two guys next to each other, and okay, I moved them. Sorry, but when I designed the first turret, I put two guys in there, and the key factor was the width. So here, let's see, we're going to go across toward the center of the turret. So it's around here. There you go. Hopefully this works. Yeah, we're good. So there you go. You have the hull. You got the tracks here. And this is the key. This is the hull between the tracks. So on the T55, we don't have the sponsoon, right? We can minimalize this, and with the turret was initially lower, was about high. And I had two figures here. So I took two Joe figures, or Cobra. And this distance was dictated by how realistically can I fit two Joe figures next to each other that is easy for me to have them side by side, in and out, and the whole turret is going to rotate. So I came up with this. Let's see if I can quickly, what is this here? Let's see. Sorry, I'm undoing some mods I did here so I can show you what I'm trying to mean here. Come on, come on. Wait, there's tons of files here. So that was the, I mocked that up with a Tamiya turret. What was it? I think that was Chieftain. Yes, it was a Chieftain turret, where I relocated the cupola and I found, hey, it can fit in a turret about yay big, about that size. And then I put another figure next to it and says, yeah, I felt this is the dimension. I can fit two Joe figures in this, and it requires me to have a basket about this width. The basket used to be deeper, but I changed that. I'll show you now on the hull. There you go. So here we go. So here we are. And the basket was deeper. And then I had to put the electronics and whatnot. So I raised it up and I was still able to fit the figurines and drop them deep enough that it was not an issue. Okay, so let's go back. So spend extra work to make it fit in a plane. Spend extra work to use two types of tracks. And that extra work paid off, because if I only stuck to the narrow track, I would have really suffered in the snow. So we knew from World War II, same thing on Sherman tanks and some Panzerfried tracks, that they added some duck bills at the end of the narrow tracks to have extra flotation on the snow. By flotation, it means we don't want the vehicle to sink in the mud or in the snow, so we need to widen the contact area. So the best, of course, is to use the Penta tracks, which are much wider. And I like them better over the King Tiger tracks, because the King Tiger is a dual link type. So when you have one link too many, you have two links too many, it's difficult. A Penta track is the same link everywhere. Very easier to adjust, better design. So that was the extra work that was done here. And the experience came from the Mauler with these Penta tracks, except the sprocket I think was bigger. So this sprocket was designed with one tooth less to fit. So here it is, right? So this is the key to mate it into a gearbox, an intermediary piece. And then if I do a cross section across, let's see, there you go. So I used to cringe about this design because I could not contain the horns. So there's like an empty tube here. There was limited meats here on the old one, so I knew in the snow it would work because snow is soft, but if I would play on the rocks or be aggressive, this would fracture. There's not much material to reinforce it, unlike other designs. So initially I was very wary of this design, thinking it'd be very fragile. Now it turned out that so far I've been very lucky. It worked fine. So this is the hole, the screw sits here, and the screw is holding this there. So that's the thing, and this is glued, is fused there. I notice in museums that some tanks are indeed open like this, and it's not an issue. At the same time, I've seen that a lot of tanks added the things in there. On most modern tanks with the rubber pads, unlike the Panther, don't have dual horns, they have a single horn. And that single horn is free to float, so if the track slop, if there's a lot of slop or slack, it can move, it can jump, and it can throw a track. So that's why they have those discs here to hold the horn, so that the track is not drifting side to side. In this issue, in this case here, we didn't have this issue, since the horns, there's two of them and they're rubbing on the side, so it's okay, it should be contained. And some holes hoping for the most of the snow to come off. So this has been successful design. I made it smaller, and here is the old one. Now here are the findings of this design that I use on Mauler. Let's change the color because we cannot see it very well. Can you see? It's kind of dark. Let's put it, let's give it a light color. Oh, wow. This be the lighting in the file. So this sprocket was designed for the hang-long tracks, Panzer 3, Panzer 4. It looked, the reason why it was chosen, it looked closer to the Moller tracks. It was black, it was the proper width, it was a single design, a single horn. It fit exactly the Moller wheels, the stock wheels, so that's why it was chosen. It worked pretty well, and the design is still very actual. It's very similar to, let's say, what the real-life Warthog used. I forgot to call the LVTP, whatnot. So that truck was chosen. However, as you see, there's the issue of the horn. So this groove is designed to keep the horn captive there so it doesn't drift. And then, you know, okay, designed to clean it. And that truck, that sprocket was okay until now. Now my findings are the following, is that in deep snow or with a lot of debris, it is not working well. So you see here, this one is designed. The screw is holding like this, but most of my video, believe it or not, I forgot to put a screw on, and it worked just fine from press fit and a bit of luck. Another thing I found too with RC tanks is sometimes if your wheels and sprockets are not screwed on, they will stay in place because the track is keeping in there. As long as there's no weird side loads, sometimes you get lucky, things stay there, and you can get lucky. So these tracks, my recent findings is that they don't work well in snow. They jump off. And as soon as you have debris or things clogging that center channel, it's an issue. And I would need to resculpt to be able to evacuate any junk from inside to the side. It's difficult. It's almost like we would need a floating ring there. Or it would be biased if it's only, say, we have only that ring or only that ring. I have not found a solution, and I just come to the conclusion that I'm ditching these tracks. They've shown their limitations, that they work well in medium sand, light dirt, but for deep snow, they're not suited. And on the Moller, another finding I found is when you have the slack from the suspension, when the suspension is compressed, you have extra slack. In real life, or even here in physics, the weight of the track keeps it on, so it jumps out, but it comes right back on. However, on most of my Mollers, what I've been using is the engine deck on top as a limiter. So there is an asymmetry that the Moller left side and right side engines are different. If you lift up the panels, you know, the engine details in there. And that implies that the bottom, like the amount of plastic that are above the tracks, on one side, there's some details below, so the track hits those, doesn't go away and comes back there. And on the other side, there's enough room for the track to wander a little more, and then it throws the track. So how does the track throw? Basically, it jumps off, and the horn either lands here or there, and then it spins, and the tooth are not in the hole, so the sprocket spins, but the track isn't, and it's an issue. It happens a lot. The green Moller has that problem a lot, and it's a liability. I don't like it. You know, you play around, and all of a sudden you lose a track. It's not cool. It's not cool. So let's go back here. So on this design here, I kind of settled with the wider track, so we can say that the narrow track is used for transport when you fit it in the plane. But so far, the performance of the wide track is really good. I started with the ratio of the gearbox, I think 220 to 1, 180 to 1. It's too slow, but that's what I had with the metal gearboxes. And there are plastic ones that work just as good, but when you drive back and forth, I know for a fact that the plastic gear, the primary, it ends up getting chewed. You've got the motor that has a pinion. It goes on a crown gear, and that crown gear has a pinion molded on it, and that one attacks. And that pinion is so small. When you drive back and forth, that pinion takes a lot of stress and ends up cracking. So no big deal. They're plastic gearboxes, replace them, but I found those metal gearboxes which were cool, except that they're cheap and the quality had a lot of discrepancies. meaning I would buy 5, 6 of them, and 3 or 4 would be unusable because poorly meshed. So one trick I recommend to everybody is when you test your gearboxes, don't feed the proper voltage. Don't put 6 volts in it. I put 1.5, so 1 battery. And the reason is when you power the gearbox at the lowest possible voltage, if the gearbox is well built, it will cycle and you can hear any issues, you know, listen for the mechanical grinding sounds. And if it has a hard spot that the gearbox stalls somewhere, you know that there's a tooth that's been smashed or there's issues. So I tested a bunch of these gearboxes until I could select some good ones. And the metal ensures the longevity that, well, unlike the plastic, you know, it's going to be a little stronger since it's smaller. So in this design, I'm limited by the motors. I'm limited by the motors, which are 130 motors. You know, here in this design, they're captive in this gearbox. And of course, more power would be better if you have larger motors, but this is what, you know, limitation of this design is. And you might have noticed from my other videos that the yellow tank used by the Dreadnoughts use a faster motor. So I modified, removed the motor, extracted the brass pinion, inserted it into a faster motor that I use on the other maulers from a long time ago. And those are much higher RPM, much higher current drain. But it is a little more interesting because we can go a little faster. If you notice, the gray swimming tank is really slow and kind of limbering around. But there's pros and cons about having too much power. The gray tank, if you notice, is all stock gearbox. So meaning when the tracks are jammed or it meets an obstacle, it just stalls. If you have too much power and the tracks are jammed or there's a serious issue, mechanical blockage, it ends up finding the weakest link in the transmission and make tooth salad. So it can be the gears, things can happen. And if you have too much power in the sense from electrical, if you have too much current, then you burn brushes and motors, or you do damage things, or electronics sometimes don't like it. So the gray tank was kind of safe. It was slow. If you notice the maneuvering in the snow, you're steady, you had to choose your lines carefully, but you did not have the extra power to get off situation. So the 10 tank that the Dreadnoughts use had a little more power, and this is the beauty of those 130 motors is you can swap them. You could find different ones, and down the road, I might be able to source better motor that would not have a too strenuous of a drain or consumption, and find something decent, not too loud, not too etc. etc. So this design, since the tank is printed and then closed, initially it's like, okay, got to design some hatches so you can access it. It's kind of a chore in most RC tanks is swapping the transmission, servicing the transmission, because those things fail. So here came the idea of the drawer, which was odd. So I used a lot of extra bosses for screws. That's why there was all these holes. I ended up using none. Just stick the motors in there and they stay there. They never went anywhere. And I've been lucky ever since. A little snap seat is like a little ramp so that the motor shell would snap there. It's not shown, but there would be a plastic shell, the gearbox. One drawback that bothered me that I could never solve is this corner here. See, the gear inside is round, but the gearboxes are not following the gear. They have those extra squareness. So this is something that real tanks don't have, is they typically try to follow the language of the transmission or have a chamfer there. So when you are in terrain and you have obstacles or you're dragging the butt in the mud or on terrain, you're not dragging the rear end. And this is a shortcoming of this design of using those gearboxes is if I start sanding the gearbox, it's going to open the gearbox, they're going to be naked and debris are going to come inside. Or I could make a shell that's a little tighter, but would have to sand and grind inside. It's work. I, for now, went with it. I wish this would rub a little less, but it is what it is for now. It's a shortcoming, and I'm living with it for now. It's okay. Now let's talk about the suspension here. This initially I wanted to use Mobat suspension. Moller. So I did some studies. I don't know where I put them, but I crammed 4 wheels, then 5 wheels, individual station, dual station. So obviously with the Moller dual bogie, there would be 2 bogies, right? four wheels, and drawn as space them. What I found out is there would be a gap in the center, or there would be a tremendous gap in the front and the back. So this is not good for wheelbase. Ideally on a tank for stability, we want to have the contact points as far out as possible. Having this wheelbase too short, the tank is going to be tippy and rocky, and it's no good. And then also you're going to let the sprocket bite the dirt too much, or the front. It's no good. And then if I move those 4 wheels further apart, I had a gap in there. And what this would mean is that the track would, when the track is loose from the suspension being compressed, the track would pick up all the slack, and if there's no obstacle, it would create a big bump. And it doesn't sound like much, but a bump here could be so radical that it would make the next road wheel struggle to go over because of the geometry. And that's the beauty in the tank, is when you have a lot of wheels following each other, it has a smoother ride, because the track, when it comes with no matter what obstacle it is, cannot take too much of a drastic angle. So it's only mostly the front taking the burden, but then once the obstacle is swallowed by the front station, it goes smoothly across most of the stations. So the 4-wheel had issues, and I used to personally believe in large road wheels. So we look again at the T54, T55, we look at the King Tiger, we look at a lot of vehicles. I used to believe that the bigger the road wheel, the better, because it would absorb and soak up the obstacle. Now, I was really planning, and this is one of the reasons why the hull is so ugly at first, is I really had, this is a remnant of it. And I had bosses. I was ready to mount Moller suspension on this. And I went the long way, which is to design both the smaller wheel and the larger wheel. And the idea was, well, I'm going to go with the smaller wheel because they're larger and more compatible. I already have the files. And I'm also going to try the small wheel. The smaller wheel look attractive because they were more in scale with the overall vehicle. But also, they were something new. So I tried them out. And I came with this flat down. So I tried in the past for the Warthog to design a suspension that was really laid down. And I wanted to have the spring actually integrated into the swing arm. And the reason was, I wanted the Warthog, when it goes in the water and mud, to not have issues of the suspension being contaminated, and to have an enclosed spring. And this way it would also look like the toy, where on the Warthog tank, when you look on these black tracks, you can see the wheels, but it'd be nice if, if you don't have those big struts sticking out. And also, if the suspension on the Moller, it's vertical, if I could lay it flat, the track above could lay further below, without hitting the suspension station like on the Moller. So here I came with a test. So I did this design. Initially it was a giant block here. And it's curved. You know, here I angled it to deviate obstacles because it's really going low. A big mount, the screws inserted from here. And I wasn't sure what to get. So I printed one, I played with it. And the beauty of this is again like motorcycle technology. So if you remember, let's see if I can view, there we go. So on motorcycle, there used to be a swing arm with the pivot, with the back wheel, and we used to have twin shocks in the back. And people discovered that when you lean the shock, you can use a stronger spring, and you've got the leverage so that you could have a plusher ride. As opposed to when the shock was more vertical, it's really stiff, so you have to use a softer spring, and it's kind of tricky with the springs, because I'm not an engineer, but some people can tell you, yeah, you can calculate those things. Well, it's almost like, let's talk like this, the envelope. You can calculate the optimum spring for your application, but then your application is an envelope. If that envelope is narrow, then you increase the weight or the speed, and you're out of your envelope. So the spring is either too stiff or too soft. It's over-damped or under-damped. And it's kind of nice when you have a broader envelope. So by experience, it's like I found, well, this is not scientific, but it goes by feel, is on the Moller, I refined it a lot until on the last model, the green Moller and a bunch of other ones, the suspension was good, at a good feel, not too stiff. Because from what I found out, the suspension has to work. If the suspension is stiff and doesn't absorb the terrain, doesn't collapse, it's not doing its job. If it collapses too much that it's bottoming and the tank is constantly hitting metal to metal, plastic to plastic, it's like there is no suspension, it's not working either. So my rule of thumb is this. If I take the whole tank and I lift it up and I place the entire tank from its entire weight on one wheel, that suspension station should collapse by 75 to 90%. If it collapses at 100%, it's underdamped. If it collapses by less than 75%, it's overdamped. So this is my finding from pure feel. And that's how I eventually came with solutions that work well. Suspension has to work. There should be a little bounce. You notice that if the vehicle is stiff like a brick, it's not working well. But if there's a little bounce when you accelerate, when you brake, when you stumble upon terrain. So the suspension has to conform to the terrain, and it also has to absorb the obstacle as you increase speed. And it is normal that suspension bottom out. On real tanks, they have actually rubber stops or metal stops, and some of them do, so that they don't destroy the vehicle or bend or destroy things but they do bottom out. It's part of the story. Just like on off-road, the motorcycles and vehicles, the suspension is supposed to bottom, just not too much. If you don't bottom it, it means you're not using your suspension all the way. So then we soften it. So here, this, once I printed it out, it felt good. I expected it to have issues because it's not as beefy as the smaller one, but I'm doing the smaller vehicle. It's working well. Now let's talk about something that's critical, which is angles of the shock, angle of the swing arm. So I've learned this the hard way when I was doing the Warthog, that when I angled it too much, it looked cool, you've got good ground clearance, it's very compliant when you go forward, but when you go in reverse, the suspension doesn't comply, it locks up. So that's no good. I would say that this one is slightly on that brink, that it looks good, it's very compliant, but going in reverse, there's a slight hesitancy of the suspension to collapse and comply when going in reverse. Now, obviously, if we look at what we did on the Mauler, the early one, when we made this distance, this line here, almost horizontal, when it is very compliant forward and reverse, then you have very limited travel. So meaning if you're going slow, so best example here is the Merkava one. So short swing arm, almost vertical line or very little angle down, because one is a leading swing arm, one is a trailing one. It works both ways really well, but if you go faster, you quickly discover the limits because you don't have enough travel. So on this one, I don't have any, let's see, we have the video, it's in the dark here, it's all sad. But I found out that it worked well. And the way this is interesting, and the way it saves is, this can actually go way up there and the spring is not compressed. The spring is initially compressed and then bent sideways. And it can actually keep on going. What actually is stopping it is the wheel touches the top, pushes the track to hit the top. So that's the stopper, that the tank is resting, the hull is resting on the track, which is resting on the wheel, which is resting on the track, which is resting on the ground. So there's not going to be any excessive force overstressing the swing arm. The other thing that happens, and let's see if I can make it appear here like this, there you go, is that this knuckle or this joint here ends up touching the track and it bottoms out. So it acts as a brake or stopper. So there's no more stress going onto the wheel to bend the swing arm or destroy it. So that's it. The other thing that I'm really proud of having done here is I was able to locate a boss to put a screw. On a lot of vehicles, what I've discovered is that the assembly, let's see if I can show it here. There you go. The idler assembly, see this guy here is, it's an assembly here. Often I found that the track is too tight or too loose. So the way to remedy this is to add an extra link, but that's too much. So then would be to make a bigger wheel somewhere or to increase the travel somewhere. It's too complicated. On real tanks, what they do is they have an idler adjuster. So you put a screw here and you can choose to push it as far out as you want. I was able here to find a design that, guess what? I never needed a screw. I got really lucky. So far, it's great. I leave it bottoming up like that. And it enables me on the track to grab my thumb and bring it forward to see what's going on. You know, like, and you can see if how the track behaves. So far, being very lucky here. So that's beautiful. One flow of this suspension, when I played in the snow, it worked really great, really happy. I spent a lot of time to design self-cleaning wheels. So on the, this is interesting. I was at a museum and I recall looking at Soviet tanks and like, their wheels are ugly. They got all this like stamped steel. So I understood why they were the way they were. It's like they stamped the steel so they didn't have to cast them or to manufacture them the way that is too consuming. And it's also self-cleaning and for strength. So I understood the way they manufactured theirs, but I didn't like the looks. Now, I discovered on the Merkava 3 and 4 that the front road wheel, or the last one, was reinforced. It was not a plain wheel that had vents and ribs, because it's the wheel that takes the most punishment. And the front and last wheel are the one that packs the most junk. So I went, and you see here in the cross-section, is I discovered the flow on all the molars is the wheel gets stuck with ice or mud or things get stuck. And when the wheel gets filled and stuffed, then the track doesn't go on it and the tracks get tighter and it either jams it or it froze the track. So here we took this kind of Soviet approach, which is like the Soviet had experience, I guess, with the mud. I think I've seen lots of King Tigers and Panther tanks stuck in the mud. And by playing with their models too, it's like they work fairly well, but they can get really stuck. So this design of having the self-cleaning wheel to evacuate the debris, I played in the past with those and I was not successful. This is the first design that was successful. It is, however, very, very labor intensive for me because when I print those things, I'm going to show you. So, for example, when I print those things, I ended up, you have to print this like this. So this is the best part and I have to sand it smooth. I found out the hard way that by not sanding those things smooth or painting those, it would paint as tooth. So sand or snow sticks to it. And anything, it has to be smooth so the track horn can just slide in there. And any types of debris, mud, sand, snow, has to slide off. If it has steps or tooth or any types of stickiness, it keeps stuff in. So we don't want that. We want things to fall off. So this was very labor intensive in a sense that I had to print those in a way that was not the easiest. And I had to really sand those things. Sand it, use some solvent on it to, sand it again. And that is the most difficult part of the making of those things. It's the road wheels. So in real life, they would manufacture this. If they were stamped, you would just crank them and done. Stamp the wheel, done, put the rubber on. I initially was going to design rubber as well to increase the tire size, but also to lessen noise. So I was going to source some rubber and I was going to make a groove to hold the rubber, a square section rubber. And then I could not do it on the inside because there's not enough plastic. So let's talk about the design of this here. Because of this design, this suspension was initially designed for the Wolverine. It was designed for the Wolverine RC conversion. And there was, because of the position of the track horn, so visualize the Panzer-free track as close as possible to the Wolverine hull. I had to design it this way with the swing arm, so the inner road wheel had to be thin to accommodate the suspension station here. And that would mean that if I put rubber on this, you either glue it or it would fall off. So I ended up ditching the rubber outer tires. I discarded it and it was fine like that. So there you have it. Other findings I found. Oh yeah, the idler. I used to always have giant idler. I ended up with a smaller one, self-cleaning. And I went way overkill on the Warthog. I simplified this. I use a gigantic screw. So let's show you this. It's overkill, but it's really to prevent failure. Because believe it or not, this was initially designed for the RC Warthog, which was very heavy. And Mauler, and I designed this part to be symmetric, so you could interchange left and right side. There would be a pivot, and if the part failed, it was intended, you just replace the part. You just put a new part of the pin, you could swap left and right. And I used to have a labyrinth seal there. There was too much junk. Those things squeak a lot, like real tanks. You know, it gets dry in there. I don't want to lube them. I used to have them with a dust cover to prevent the head from showing off or being exposed. I found out it's okay, just leave it with slop. And this design, it actually is from the Merkava again, which itself is from the T55 or T54. This kind of scalloped outer wheel. They even have holes actually on the Merkava. And it's like we don't need to have a solid road wheel. You look on the Leopard, they have rubber. They have a solid wheel that's constantly rubbing on everything. Leopard used rubber padded tracks. The T54 and 55 and Merkava use metal tracks with harsh condition, rocks, sand, you name it. So this, initially I thought was, yeah, it's kind of attractive design. I found out it actually is very functional. It is a very good design, and you see here the shape is I had to find a way to streamline, things have to evacuate. This is difficult to sand inside. If I spend the time so that the snow doesn't stick, evacuate everything. No holes on this side because then we're going to jam this. We just want to channel everything outward through the channel there. So this worked really well, very happy with this. Now let's go back to the choice of wheels. So I made the small wheels. I expected them to be somewhat okay, but I found out actually that they were better than the smaller wheels. Why? I always thought, like I said, that the bigger wheel would be better to absorb obstacles. And I found out that the small wheels work just fine. But also they enabled bigger travel, because a big wheel would only move so much and it would hit the upper sponsoon. Well, here what happened is that the, oh, wrong file. The, oh, where is it? I lost my guy here. Just a second, I lost my train of thought here. Is it this one? There you go, there you go. So the big wheel would have very limited travel, and there's the thickness of the track, mind you. So the small wheel enabled more travel. And then as you can see in some of the early videos, I found that the off-road performance, slow speed and high speed were very attractive. Higher ground clearance than the Mauler, higher angle, higher curvature in the front. So it didn't get stuck like the Mauler as much. There's also an angle. I don't know if we can see it here. The hull is, the belly is not really horizontal. It's got a little angle. And because of the weight of the motor, it's riding like nose high like this. And that in the snow worked wonders. It's wedging itself across the soft snow, as opposed to the traditional box horizontal hull that, you know, the corners pushing stuff and it's bellying itself from the get-go. This is kind of, you know, helping itself through. It's like a snowmobile kind of thing. You let the nose go up like a boat, and then you have the momentum and the weight to squish the snow with the rear end that touches. So that was very successful. That's the finding I got here. The small wheels work wonders. The only drawback was these guys here. If you look here, imagine you're the snow coming here. You got all these things scooping you. So it would scoop snow and the snow builds up in the back and it would pile up front. One issue I found, depending on the type of snow, is snow builds up on top and creates a block of ice between the track and the suspension, and it slowly builds up and reduces the travel. The worst case scenario is that it builds so much that the suspension is limited to a point that it's not collapsing anymore. The tank can still move around, but you lost your suspension travel. So it is a little shortcoming. It has happened only once so far. I think it has to do with the type of snow. The consistency, the stickiness, the temperature, all these things. I still have to do some sand testing. So far I did not have springs do weird things. So far I would say it's going pretty good, very happy. What else? So now let's talk about this platform, if you're still here. So the Cobra Swimming Tank showed up, and there was the idea of what if we do different vehicles on it. And, oh shoot, okay, let's hide all these guys here. Since this platform is working so well, I came with the idea of, hey, what if we do a Mobat? Why? Because the Mobat is so iconic, and I want to do it with the crew inside again. So it's this philosophy of a small compact tank. The guys in the turret, there's nobody in the hull, because if I put a guy in the hull, it would create a giant, you'd have to lengthen it, then the tank becomes bigger, it becomes a nightmare. So what the other things, I considered making a his tank. Oh, here's the Warthog. So let's show you here. Come on, let's see where all my are the parts here. Okay, there you go. Okay, so here we have. So the Warthog, the baby Warthog, how it started was, let's make an APC. Because from the get-go, this new platform, I wanted to have the tank, but also I wanted to have the troop carrier. Let's see if I can find the figure. Fig. Is it this one? There you go. There we go. Let's go inside and hide this sucker for the sake of clarity. This is the partition. Let's hide the cover. There we go. Let's hide this distracting piece. There you go. All right, so now let's go. So the APC. So I played around with different angles. I initially was going to have the engines in the front, but as you've seen that the angles, the corner of these gearboxes mean that if they're in the front, you need either the bigger sprocket or you need the reduction. And you don't want to go that route. I've done it on the Warthog. It's extra work and it creates weakness. So I decided let's keep with the rear wheel drive. Keeps the cleaner slack of the track. I can bring the idler the way I want it with the proper belly I want. It's cleaner. Weight in the back, it climbs better. So all the performance advantage. And then let's have a boat hull, and I was going to do an APC with a small turret and troops in the back. So the troops in the back were not like the real APCs and BMPs and whatnot. In our case, they would be just sitting outside. So a couple of things. Okay, let's see here if the computer can hold of me. If it's amphibious, you see here I trapped air in those sponsoon. I'm going to show you here. So there's a gigantic amount of air trapped on the sponsoons for flotation. That's the drawback of the real Warthog, is it fills up with water and then it sunk. And it only worked when it floated like a bucket, basically, meaning it floats, but the moment you have water, it fills the bucket and it sinks. So here, to remedy to this was to trap as much air as I could. Now, that is if you make it amphibious. But if it's not amphibious, we could drop the guys. So see, for example, here, we have the guys seated here. So we could sit a bunch of guys, get rid of the side sponsoon of all the air there, and we could have the guys. Or we could have the guys on top. So either way, we could have guys standing up from here and in a small turret. And then I played around with this. So this is, it doesn't really come well in the video, but I'm very happy with this. It's like the Wolverine. So you get the figure sticking out. But I was able to, let's see if I can make it happen here. You can actually hide the entire figure. Let's see if I can, come on, there you go. I was able to fit the figure, the Joe figure, to a point that you can have a hatch and close it. So see, there's a little seat there, so that worked against me. I had this seat bigger and then I made it smaller. So when it was bigger, it would have enabled the guy to rest on it. Now it's a little too small, so the figure slides off this edge here and just falls down. But basically here I've been able to find a compact compartment that enables a figure to stick out realistically or to be fully buttoned up. So I did some kind of BMP design with a long nose angle, and I came with a couple of concerns here, which is if you have an angle in the front and you have water, that water splashes on the guy. So you need to have like a raised cupola, like a boat, or you need to have a folding plane here, or you have to raise the nose really tall like the Warthog. Here I went with this compromise, which is I wanted to capture the essence of the Warthog. Let's hide the Panther track here. And so it's style. This is cosmetic. And of course, if water splashes, it would go on them, so they would need to have a little edge, you know, a little thingy. And I designed it so that if it gets filled with water, it still floats. So I did some tests. I don't have the pictures uploaded yet. But this hull floats properly. And it won't sink, even if flooded with water. So it floats like this at an angle. So the water line starts here, and then it gets there around there, depending on the load. So I put some screws in places. So it does about like this, 1/4 here, and it goes like this, which is really good. Of course, if the water is bumpy, it's going to be water everywhere, and it doesn't sink even if this gets filled with water. This is the compartment where there would be the dry chamber. So that's why on top there was a lid. The batteries and electronics would be there. The motors get flooded. The compartment here can have a pool of water, doesn't matter. These guys can be flooded, doesn't matter. Of course, what I can do is minimize the volume here to trap as much air as possible and only have room for the figure. So this is something here that I'm kind of happy I did here, is I position the guy so that their left arm and elbow is resting against the sponsoon. Let's see if I can show you here, this here. So we go here. There you go. See, so that is an efficient use of space as opposed to have them only in the middle or do weird things. So that's pretty cool, you know. And these corners, in my opinion, are wasted. So if we could optimize it so that where their feet go, just have the strict amount of minimum. We don't need to have room in the center, so there could be a giant bump in the center to trap more air, and only allow the air in the middle, in those compartments, just for the figure to go in and out, nothing else. So when it gets filled with water, it's not the least amount of water, the better, because it changes the flotation line. So this platform here, a couple of things. It was a test. It's kind of a meh as far as a Warthog. I'm surprised that the video got so much views. I don't know if it's positive or negative, but I wanted to test it. I did it. 2 nights of printing, lots of solvent to seal it. It's a meh, really, because I don't know. It's maybe too simple, whatnot, but it's just a test. So what I learned here is, we know we can do different angles. I could position this higher, further back. We could make this an angle with a turret. If I want to do a hiss with adjustable suspension, we could raise it, move this up, have more overhang, a glass canopy if you wanted. So there's potential to do more things there, or do the troop carrier we talked about. Or if we do a regular tank with a hull-mounted driver, this is the amount of room I found to put the Joe figure. So it's substantially taller. Let's see, I'm going to overlay them so we can see. I'm going to hide this guy. I'm going to hide this guy. And let's overlay. There you go. So see, this is the thing. Let's overlay on it our regular tank so you can see. There you go. Where's our turret? There you go. So in a sense, when we have the guy in the turret and we have a guy in the front. So if we were to, let's say, okay, there you go. If we were to have a tank with a real turret, let's say we could have the nose here flatter. We could have a glacis here. And this guy here gets hit by the gun, which is the issue. So either he has to duck down or that's all kinds of issues. But yeah, this gives you an idea, right? If we put a turret and we have a guy as well, what it could look like. Maybe we look at the gun higher, like on the Mauler, or it's an artillery case with a, a bigger turret with a higher gun. So This platform is interesting, you know, without changing the wheelbase and the width so far, we can do a lot of things. Yeah, so all the files are on Thingiverse. I welcome you to play around, see what you can do. But overall, this platform is working really well, as you have seen in the videos. There's potentials for more. You know, we got our MOBA turret here. Let's see what will happen. You know, it's all overlapping. You know, like what else we have here? Like, oh, this one is. Oh, that one we cannot erase. But anyway, so there's if you have a printer, I think this could be done in PLA and you glue it. I am not sure that I've included inserts, but it helps to glue the part with some. Let's see if I have them, the inserts. There you go. I'm going to show you what I mean. Tick, 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 tick. There you go. And the inserts. So when you glue, sometimes it's misaligned and then it dries and it's all messed up. So the idea is to sandwich some inserts in between the elements so it cannot be askew. It's perfectly in line, and then you seal it. It really helps. The reason those are not part of the file is when I print, it's easier if it has a completely clean flat spot. Because of the warping here, you see I'd try a staggered step. It didn't help. But yeah, you can see here, let's see, I'm gonna make those things like this so we can really see. There you go. Here you can really see what I'm talking about, the inserts, right? And you mirror that. And then at the bottom for strength and also to perfect. But this is how this is made. The water can come from these holes. You can use some silicone or some sealant. I initially had the wires going up with the channels, ended up not working, and I ended up deleting that. So that's the prototype number 2, which is T8, which is the yellow tank. So it's the streamlined, improved hull. I sealed the bottom. It used to be completely open. There was room for legs. I changed that. This is an afterthought. To be honest, initially I was going to put the batteries and the electronics there, and I found out in early testing that there was too much weight bias from the rear with the weight of the metal gearboxes. So I relocated the battery in the front, and then this ended up being empty. So I sometimes use this for troops like a pickup truck, but the covers and all the things, I ended up not doing anything with it. There still is a channel here for the modules, the jet modules or the other accessories, the jet. I was going to redo the hull, incorporating the chambers for the electronics, the batteries and whatnot, built in the hull pieces. That's a major rework, so I ended up just putting some modules I graphed on for now, but down the road I'm going to rework it. But for now it works fine. It is what it is. If you're able to print those things with clean mating lines, it is completely watertight. So obviously, if you don't have this guy here, there's a wall here, so the water can only come from the holes, from the motor wires. The reason I made them so big is like so it's easy. You don't have to snake them through. It's easier and it's not a pain in the butt to snake them through. And then you can put your silicone plug in there. But this is sealed. The front one here is tricky. That seam here, that one has to be done well, otherwise you get water in. One note though is the gray prototype I showed, the early one, that one was tested by flooding everything. So I did not care about getting water in. The electronics were in a box. The water, the spoonsoons were sealed, so those were sealed, but the hull was totally flooded. So that was not an issue. And depending on the volume of air trapped in the battery box or adding foam blocks, it doesn't matter if water slushes around. Now, a little word is I actually had a design when I had water jets shooting from the side. So axial to these motors shaft, there were turbines here with water jets. And I found it very difficult to find a way to not hit the tracks because the suspension moves. Let's see if I can show you here. Okay, let's hide the Warthog. Let's hide the Mobat. And as you can see, it's difficult to find a clean pathway. The track comes here, so this is not a viable option. Then I actually was aiming at a jet that was shooting really between, you know, we're saying where the road wheels work and the track works. So it was very inefficient and have some louvers and channel the water back. So there was actually a design where the motor inside, there would be a second motor, or in line with those, as the tracks turn, you have those things turning. There were also another design where I'm using this other end shaft here to spin a bunch of gears to spin a propeller. So there are a couple of drawbacks with this, is that these gearboxes are really slow. And then the output shaft to bring back the realistic prop speed means I have to have a bunch of gears to bring back the speed needed. And then that is also acting like a flywheel. So when you drive forward and back, you've got this friction. And because of mechanical advantage, if the propeller is blocked, it stalls the motor. Because it's a demultiplication. Since the propeller is increased, the slightest drag on the propeller acts as a tremendous brake on the motor itself. So that's one of the reasons why I didn't pursue that, because it seems like it's doomed. It's enough disadvantages I can foresee right there that I didn't carry through. Another option is so that's where I was leaning, is to have a third motor that's got a propeller or a jet, and then there would be a steering nozzle, left and right and up and down, from two servos. So that means that in the center here there would be two servos, some linkages, an articulated thrust nozzle, a jet or a prop motor here. And then to simplify this should be thought through and integrated with the hull or the interior compound. Let's see if I have this guy here. So far this is the housing with the battery. And I'm thinking of, I've been sneaking everything from the top, from the small hole, which were smaller, and it's a pain in the butt. So the other option is, okay, let's make a bottom with a seal, some screws and an O-ring so that we can access all that stuff and we can make it larger. There's quite a waste of space there, and also intended in the original swimming design was the ballast system. So they were initially, the electronics case was smaller, and there were two syringes on the sides, bellows, like compressing air for. So the concept is you achieve neutral buoyancy as close as possible, and then by using this ballast we can decide to have the vehicle surface or sink. It is evolved, it is fun, but for now it might be easier to, I would have to test those things, and then once they work well, refine them. It would be cleaner if they were integrated in the design of the hull itself. So that's another iteration. So for now I'm enjoying using the hull that is working very well, but for the fully submersible one, I actually had one when the whole bottom was cut off, so there would be a bottom tub that has all the submarine equipment. And the reason I didn't pursue this is it weakened the whole thing. So the strength of the hull was only this upper part here, and there was a giant cut here. So it was flexing, it was, you know, so once the design is refined, then we can integrate with it. But the submarine stuff has to be accessed, and it has to be sealed because water always finds a way inside. There's a lot packed on it. This is a fun project. It's a fun platform. Let's talk about the turret here. Let's see if I have it. Let's see if I have the turret. There's so many files here if I can find it. Huh. Let's see. Oh, no, that's not it. Do we have the floats here? No, this is the Muller decoy. You probably have seen this in my other videos where I also considered doing the Muller 2.0 or baby Muller. This was done really quick and hastily, so the proportions are off. The turret is too wide. But it was like if we put some add-ons, bolt-on armor to make it look like a Muller, and there was also the barrel and all that stuff. But that's not what I want to show you. I want to show you the floats, the one you see in all the videos, if I can find it. Huh. There you go, on it. There you go, the floats. So it's very minimalistic. Oh, this is a newer version I never printed where I put bulgers in the back. So let's explain what this was. Initially, it's the idea to put reactive armor or add-on armor, the way it's done on the Soviet tank, but also on the Merkava 4. And then it completely changed when I was mostly looking at from a submersible point of view. When I put the tank in the water, before I did, it's like, well, if it's a swimming tank, it's got to be able to float. Let's assume that it's too heavy and there's not enough air in the hull, so it needs Cobra needs to make the tank float. So what they're going to do is they are going to bolt on some slightly substantial armor, but it's mostly a flotation aid. Who says flotation aid? Mean, okay, it's empty spaced armor, and that was the concept. I did not spend too much time to make a fancy shape like the Russians or the Merkava, so I ended up doing like a saucer. And the idea was I want to trap as much air as I can to help the tank float. Now it turns out that it worked, but the tank was too tail heavy because of the motors. So I said, okay, I need to put more air in the back. And also, if I make this floats too big, it would float well, but it didn't look good. So from ballistic points of view, of old school ballistics, let's make this like the Gundam, the High Gog. Make this thing very organic, very aquatic, very crustacean, like a crab. So let's make this, it was not intended to look like a saucer. It was intended to be part ballistic, but part armor. Yeah, so it's a little of armor, but it's mostly flotation, and it has to be practical. And then, of course, they are the aesthetics. Okay, so let's drop this guy here. So it's like something like this. Okay, I'm approximating here. So I had to clear the rangefinder, make a cut in the front so all the sides are clear, clear the periscope, big cutout in the back for the hatch. And there was also a plan for a pannier in the back, can come later. Oh, by the way, do you guys notice there's a periscope? I was going to put in here the handles and the screen, and the thing sticks out. So when the Cobra tank's in the sand, just like an octopus in the bottom of the sand, and this thing sticks out, let's look what's going on before the surface and do things. So the turret, which was intended for flotation purposes, ended up actually being part of the style. Because the cast turret appears to be a little too ancient. It's post-World War II. And it's Cobra, so to give it a little style, that very angular, flat, scoop turret, kind of gave it its identity. I was going to have some details on it, hooks and things, and maybe attachments so that figures can be hanging onto it. It can come later, but for now, this is what it was. And also something very odd that is very atypical of tanks is typically the turret is never wider than the tank itself. And I printed those things. I didn't want to spend too much time with all the work and other things. What I found out is when the tank is going off cambers and actually is like leaning, it saved it a few times. Since this is not weight, it's empty. It kind of helped so that the tank did not roll over. So you might have seen in some of my videos is that this thing helps it. In real life, it's a hindrance because it's going to smash other vehicles. If you go in a street or you go somewhere, you have to remove those things because they're in the way. And there's another inspiration here, which is from the nuclear tank, the Object 279, where they added some UFO saucer-like things on the hull. And the purpose was to deflect the nuclear blast so that the tank doesn't roll over upon the explosion. And those were add-on empty things that are hinged on the hull. So when they transport it, it's narrow, it fits the train, and then when they go in combat, they unfold it. So here it's safe to say that the Cobra troopers would remove those lightweight things when they don't need them. But then when they're on terrain, on the field, they put them on. It's got its look. It's fun looking. It's not really the greatest amount of protection. I don't know, it's just the fantasy of this thing. Alright guys, this has been a very long video. If there's any IDs or things you want to modify, if you notice my files, there's STL, but there's also step files, solid, so you could modify them. I welcome you to modify, do your own creations, because we here have a system. We have a platform of a turret, gun, suspension, drive system. You can make a track vehicle very easily. So you might have seen in my other files, you don't need to have this wacky hull. You could cut, make it a styrene, or use an existing vehicle you like. The beauty of the system is you can decide the width that you want. You could make this narrower or wider, as long as you respect the alignment of the sprockets and tracks and ample room for the tracks, so I have proper sponsoon. That is a very friendly track platform to have fun with. So please, by all means, enjoy those things. Post your creations, modify them, see what we can do. There's a bunch of other projects that I didn't get to, which was the adjustable suspension. Believe it or not, but the tank was supposed to have adjustable suspension, so it could squat, similar to the Japanese. What was it? The Mitsubishi tank, I forgot, when he had a hydropneumatic suspension, just like the MBT-70. And little fact, before I did all this, I was actually investigating an S tank for Cobra, or G.I. Joe as well. So there was this whole concept of 4-road wheels with adjustable suspension. For the amount of complexity, it's really cool, but it really eats a lot. And at the end, I ended up, moving forward. Biting too many things at once, but those are little things that could always be implemented down the road. But the squatting, as cool as it is, the one reason why I could see that I might investigate it is in the snow, especially in deep powder, the highest ground clearance is the best. So if the tank is too high, it has issues. So this is a very decent height and proportion ground clearance. But if there was a way to actively control the suspension to make it higher, we could make the Cobra his tank, and we could make a vehicle that could work much better at the bottom of the ocean or on very deep snow. So adjustable suspension is something that we should not negate. We should at some point address it. For now, it is what it is. Again, enjoy these things. Thanks for watching.